Hey guys, 7.5 intro screencast. So there's going to be another one that comes a little bit later while I go over the practice, but this is just the intro. So in your notes, I'm just going to read, remember when we solved a quadratic equation, whether we used factoring, completing the square, or the quadratic formula, we're looking for solutions or zeros, which are also called roots of the function. Can also be done by graphing, as I've shown in the past. So just to refresh our memories with an example, I have one of the graphs here. So here's, if we had to solve this equation, we could use the graph. So where we would find the solution on the graph is those x-intercepts. So there's one and there's another. And I would just need to count how many. So this is 1, 2, so I'd have x equals 2. And -1, -2, -3, -4, -5, and x equals -5. So those would be two solutions of this equation. The other ways we've talked about is factoring, which you can see here. So to factor, right, x squared plus 3x minus 10, I could do the area model. So I have to do x squared and -10, and I need two numbers that multiply to -10 and add to +3. So those two numbers would be a +5 and a -2. So I would have 5x and -2x. And then from there I can factor. So pulling out the common factors, I have the 5 here, x here, and the -2. So that one's a little bit hard to see. So the factored form would be y equals x minus 2 and x plus 5. And then to continue solving, we would use the zero product property. So I would have x minus 2 equals 0, or x plus 5 equals 0. And I would just solve that. So I would add 2 to both sides. So x equals 2, or subtract 5 from both sides, so x would equal -5, which is the same thing I found when I was graphing, x equals 2 or x equals -5. The third way we had was the quadratic formula. So just again, one more refresher here. So again, the equation was y equals x squared plus 3x minus 10. So in the quadratic formula, I need a, b, and c. Whoops, b doesn't equal c. I need b and c. So a in this case would be 1x squared. B would be 3, c -10. And we would use quadratic formula. So we have x equals -b plus or minus square root b squared minus 4ac divided by 2 times a. And plugging in our numbers, we get x equals -3 plus or minus square root of 3 squared minus 4 times 1 times -10 divided by 2 times 1. So x equals -3 plus or minus the square root of 9 plus 40 divided by 2. X equals -3 plus or minus the square root of 49 divided by 2. Square root of 49 is 7, so I'll split this, and x is -3 plus 7 divided by 2, or x is -3 minus 7 divided by 2. This is -10 divided by 2, so x would be -5. And over here, I would have 4 divided by 2, which means x is 2. And again, going back, same solutions. X equals 2, x equals -5. So 3 different ways: graphing, looking for x-intercepts, factoring, or quadratic formula. Okay? So, we know how to do all that, so why am I going through it again? Well, we're introducing something a little bit crazy. So what happens if we graph the equation and it doesn't cross the x-axis? Like we don't have these pieces here where we have actual x-intercepts. What happens if this doesn't happen when we graph it? Since there are no x-intercepts, does that mean that there are no solutions? Well, not exactly. It means that there's no what we call real solutions. Instead, we have imaginary or complex solutions. And this is what we're really talking about today. So you see on your paper, it's like, what? Imaginary? Like I didn't have a hard enough time with some real numbers, now I got to go and imagine some numbers. Well, relax, it's just one number, and it just helps us with some negatives under a square root. Okay, so some definitions for you. Imaginary or complex numbers arise when a quadratic equation produces a negative number under the square root while trying to solve for x. Since you cannot take the square root of a number, go ahead, try it on your calculator, any negative number. What happens is you get an error on the calculator. Even on your phone or any calculator you use, you're going to get an error. So instead, we use an imaginary unit. We call it I for imaginary. And I squared is equal to negative 1, which means that I is equal to the square root of negative 1, which allows me to pull out a negative number and then continue to square root. So let me show you what I'm talking about with the next example. So the next example that I have, so the next example here is asking us to solve y equals x squared plus 4x plus 5. And I went ahead and graphed this, and as you can see, there's nothing touching my x-axis, so I have no x-intercepts. So what are these imaginary numbers? How do we find them? Well, you'll see in the next one here, it says factoring. I cut it off, but it says factoring. If there's no x-intercepts, should take a note here. So no x-intercepts. X-intercepts means complex solutions and not able to be factored. So factoring here is not possible. Factoring not possible. Okay, so instead we have to use the quadratic formula, which is why I left you some more room there for the quadratic formula. I'm going to go to the next page, so pause as needed. So we have the equation y equals x squared plus 4x plus 5. Nothing changes here. I still need to know a, b, and c. And I'm still using the quadratic formula, which is that x equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Still using and plugging everything in the normal way. What's going to happen is under that square root, we're going to end up with a negative number. And that's where the imaginary unit comes into play. So a is 1, b is 4, c is 5. So let's go ahead and plug these numbers in. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 5 divided by 2 times 1. So we get x equals negative 4 plus or minus the square root 16 minus 4 times 1 is 4 and 4 times 5 is 20 divided by 2 times 1 is 2. Okay, so here's where it happens. Continuing this, we get x equals negative 4 plus or minus the square root 16 minus 20 is negative, negative 4 divided by 2. And here's where in the past we would try to put this in the calculator and go, it's giving me an error, and I would tell you, well, you're doing something wrong because we haven't learned this yet. Well, here it is. We're learning it. So how do we calculate this if the calculator doesn't let us do it? This is where that imaginary unit comes in. So I'm just going to go to a new screen, and I'm going to take this with me. So I have x equals -4 plus or minus the square root of -4 divided by 2. So the question is, and here's some notes for you, so get them down. How do we take the square root of a negative number? Okay, so here's where we use the imaginary unit. That's the solution. So use the imaginary unit. So the square root, here's how this works. The square root of -4 can be broken up into the square root of -1 times the square root of 4. Because -1 times 4 is -4, and now I've broken it up. Well, remember, back in the notes, it says right above this example that the square root of -1 is equal to I. So here's where this comes into play. The square root of -1 is I. Notice I put the little lip on it on the bottom here because that way it doesn't look like a 1. So it's I, and we know the square root of 4, that's 2. So we have I times 2. And I times 2, just like if we were to do x times 2, we would write 2x. So I times 2 is 2I. So the square root of -4 is equal to 2I. A little strange, I know, but just go with me, okay? So we come back up here, and in place of that the square root of -4, I'm putting 2I divided by 2. So your last step now is to divide everything by 2. So we have x equals -2 plus or minus, because -4 divided by 2 is -2, plus or minus 2 divided by 2 is 1, so plus or minus 1I. And this is our solution to example 2. Okay, it's two solutions. We could write it, if you wanted to, as x equals -2 plus 1I, or x equals -2 minus 1I. So there are two solutions there. That's what that plus or minus means, remember. I just kept it as a little bit simpler so that we don't have the two different numbers. Okay? We're going to do another example, so if you didn't get it, or you're still like, huh, what? This isn't real? Well, it's not. It's imaginary. Haha. Okay, just kidding. All right, so next page, vocab note. The -2 plus I, or 1I, either way, because when you multiply by 1, you don't actually need the 1 there. So I could get rid of this if I wanted to, and just have plus or minus I. So -2 plus I and -2 minus I are called a conjugate pair. Here's some more vocabulary. Be ready for a do now quiz, because they are in the form of A plus BI and A minus BI. So that's your complex number. They are also called complex conjugates because one number is real. The -2 is a real number. We know that as a -2. And the other is imaginary because it has the I. Okay, so let's go over example 3. I'll talk a little bit more about some of that vocabulary that I just threw in there, the conjugate pair, complex conjugates, real, imaginary. I'll go through all of that with this last example. So again, example 3, you might be saying, like, well, how do I know if I'm going to have an imaginary solution or a real solution? Well, the simple answer there is to graph it. If you graph it, like I said before, if you graph it and we don't touch the x-axis, whether the graph is facing up like that or maybe it's below like this, either way, if the graph doesn't touch the x-axis, you're automatically going to have an imaginary number in there somewhere. You might have a conjugate pair or you might have complex conjugates, but either way, you're going to have an imaginary number in there somewhere. So if the graph doesn't have x-intercepts, what does that mean? Factoring is not possible. So I'm not going to be able to factor this. So you'll see I have quadratic formula, which we'll do, and then I have square roots because there's actually, since there's only one x in this problem, there's an easier way to solve it than using the quadratic formula, but like we know, quadratic formula will always, always, always work. So let's see if I can fit quadratic formula in this nice little space over here. What are your bets? Probably not. Okay, so A is 1. B is missing, so it's 0, and C is 3. Quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. So x equals, b is 0, so the opposite of 0 is just 0, but I'll just put in the negative, plus or minus the square root of 0 squared minus 4 times 1 times 3. Divided by 2 times 1. X equals 0 plus or minus, 0 squared is 0. So 0 minus 12 divided by 2. X equals, I guess there's no point in writing that 0 anymore, plus or minus the square root of negative 12 divided by 2. So there we go with that negative again. So what do we do? Well, we're going to take out the negative and take out any perfect square factors. So let's say x equals plus or minus the square root of negative 1. So I'm just going to find another way to write negative 12 with square roots. So perfect square factor hiding inside of negative 12, or hiding inside of 12, now that I've taken out the negative 1, is 4. So I'm going to put a 4, and 4 times 3 is 12. So I took out the negative 1 so that the negative is gone, and then the 4 times 3 makes 12. So the square root of negative 1 times 4 times, sorry, let me start that over again. The square root of negative 1 times the square root of 4 times the square root of 3 will give me the square root of negative 12, because negative 1 times 4 times 3 is negative 12. I'm dividing that by 2. So let's simplify now. The square root of negative 1 is that new number we just learned, I. The square root of 4 we know is 2. The square root of 3 is not a very nice number, so we leave it as square root of 3. This whole thing is divided by 2. I know I'm coming down to the end. See what happens when I try to squeeze things on here? I'm going to erase the top and go back up. So I have x equals I times 2 times square root of 3 divided by 2. Okay? So the square root of negative 1 is I, the square root of 4 is 2. The square root of 3 is ugly, so we leave it as the square root of 3. And we divide by 2 because that 2 on the bottom was there. Okay, so do your division. I can cross out 2 divided by 2. They cancel. So I'm left with, and I forgot my plus or minus, sorry. I'm left with x equals plus or minus I times the square root of 3. Okay, and this is my answer. This is called imaginary because it has the I. So the square root of 3, even though that's a real number, because it's multiplied by I, this whole solution is an imaginary solution. Okay? It also has some other vocab that goes with it, and I'll go through that in the next, section. So that's the way to solve with a quadratic formula. As I said in the beginning of this example, we didn't actually have to use the quadratic formula because there's only one x in the problem. So I could use square roots, which is a lot easier. So let me erase that. So now we're jumping over to square roots. So to solve with square roots, you're just basically following your undoing operations. I have x squared plus 3 equals 0. So again, because there's only one x in this problem, there's not x squared plus 3x or x squared plus 5x plus 2, I can just simply solve the equation almost like a linear equation. We subtract 3. So x squared equals negative 3. And then how do we solve for x when we have x squared? Well, we square root. So square root of x squared and the square root of negative 3. Square root of x squared cancels those and leaves me with x equals square root of negative 3. But again, not allowed to have square root of a negative, so I have to pull out my negative 1 times square root of 3, and the negative 1 turns into the I. So x equals I, and I forgot my plus or minus again. Yikes, don't do that. When we square root, we have the plus or minus, plus or minus, plus or minus. So it turns into I, because the square root of negative 1 is I, times 3. And that's the same solution I got with the quadratic formula, but I didn't have to erase and rewrite because it actually fit, because it's nice and tiny. Okay, so remember I said that that plus or minus I times the square root of 3, that is called an imaginary solution. So let me just do a little bit more vocab. You can go down to the bottom. So plus or minus I times the square root of 3, we already said is an imaginary solution because it has that imaginary part. It has the I. So we have an imaginary solution. Okay. You could also write this answer as positive I times the square root of 3 or negative I times the square root of 3. If we write them like this, these guys are called a conjugate pair. Nope, that's a J. The G comes later. Conjugate. They're called a conjugate pair. So if you go back to your notes, conjugate pair, because they're in the form of A plus B times I and A minus B times I, but A is 0. So because there's only an imaginary part, they're a conjugate pair. Okay, so conjugate pair, not complex conjugates, because there is no real part. Okay, so they're called a conjugate pair, but not complex conjugates because there's no real part. If you look at the solution to number 2, and I'll put that on the next slide. So example 2's solution was negative 2 plus I and negative 2 minus I. Example 3 was just positive I times the square root of 3 and negative I times the square root of 3. So these guys here, example 2 solutions, are the complex conjugates, and these guys here are just a conjugate pair. So that word complex really just means that you have a real part and an imaginary part. So this is the real part and this is imaginary. Okay, same thing here. The negative 2 is the real part, the negative I is the imaginary part. Because in example 3 there is no real part, there's nothing being added or subtracted, these are just imaginary. All right, and we'll see some more practice with this. We're going to do an investigation on it during our next class, and we're going to do some more practice as well so that you get a handle on it, because I know it's a little bit weird, these imaginary numbers. All right, hopefully you took some good notes. Makes a little bit of sense. You can kind of get an idea as to where we're going with this. I'll see you in class.